Hi everyone, welcome to the third town hall for Nervos. Today we're going to be focusing on some of the ongoing grants that are being developed as part of the Nervos Grants program. I'm Ben, Head of Operations for Nervos Foundation, and today we're joined by three of the grants teams that are currently building on Nervos Network. We're going to have a presentation from each of the grants teams on their progress so far, and then we're going to end with a Q&A with all of the three teams. So if you have any questions for any of the guys, please post it in the chat. So without further ado, I would like to introduce Phil from Obsidian Labs, and he's going to be talking about their CKB Studio project. Take it away, Phil.
Hi everyone, this is Phil from Obsidian Labs. A few months ago, we released CKB Studio, which is a desktop IDE for CKB script development. We kept working on the project, and today I'm very excited to announce the web version of CKB Studio. With the web IDE, you can open it anywhere with a browser and start developing on CKB immediately. To use CKB on the web, open ckb.obsidians.io in your browser. If you come here for the first time, you'll need to log in, and we use GitHub for signing up. Once you're logged in, you will see a project list on your home page. The web IDE will manage your projects on the cloud. For example, when you create a new project, so let me name it as my first project and choose Rust as the template. We are going to use a dedicated server to create the initial files for you. So when you click the create button, the server will run this capsule new my first project command to create the initial files. So let us wait a few seconds here. Now the project is created, and you can open it and start developing it with this full feature editor in the browser. These will have all functionalities as the regular desktop IDE. For example, you can browsing around the project files, and let me open the main source code file here and make changes to the code. All files are managed and saved on our cloud server, so you can access them from anywhere with your account. We also integrated the CKB compiler. This is a Rust project, so we provided Capsule as the project compiler. If you create and open a C project, we also provided C compilers for you. On the back end, we have a server for project compilation on the cloud. So when you want to compile the project, what you need to do is just pressing this build button, and we will automatically compile the project for you. With some optimizations, in many cases, it's even faster to use the cloud compiler compared to the desktop IDE. So it usually takes like 20 seconds to compile a Rust project. And let's wait a few more seconds here. Okay, the project is compiled now. The compiled binary will be pushed back to the project so you can see it, for example, in this build folder. The web IDE also allows you to deploy the compiled binary by right-clicking the file and select this create cell item. So you will be able to write the file content to the CKB blockchain. The web IDE also provides connections to the CKB networks, like there are Agron testnet and the Lina mainnet. You can easily switch between the network by clicking the item. So if I want to switch to the mainnet, just click the button. You can also configure a custom network if you want to connect to your own CKB network or CKB node. So it could be a node running on your own local machine or another RPC address you want to connect to. Okay, another component of the IDE is this transaction constructor. This is the place where you can construct CKB CKB transactions. The way to use it is at the bottom, you can type in an address and search for the live cells associated to this address. The cells are the ingredients of a CKB transaction, so just drag and drop the cell to inputs or depths. On the right side, use this output editor to build output cell. It should be very intuitive to understand these parameter inputs. So for example, there are capacity, the log script, type script, and data. Another way to construct a transaction is using these toolbar buttons we provided. For example, this is a button to construct a transfer transaction, and this is the button to mint some UDTs. So let's take a look of the transfer button. By clicking it, a pop-up window will show up, and you just need to type in the amount of CKB you want to transfer and select address here. And press the preview button. The transaction constructor will automatically search for available cells and construct the transaction for you. If you are satisfied with this transaction, click this push transaction button and sign the transaction, and you can push the transaction to the network. The IDE has integrated Key Pair Manager on the bottom left corner, so it allows you to sign the transaction. We use a queue to process pending transactions, so you can see the transaction we just sent is showing up here in pending state. The cells used by the transaction will also be set to either pending state or unavailable state, so the IDE would know they are not available because they already been used when you want to create or build another transaction. Now the transaction is confirmed. So let me show you the last component, which is the Explorer in the CKB. And in the Explorer, you can search by address and look for account information, and also the transaction histories. So let us open the recipient of the transaction we just made. And we can see in the transaction history, this is the 5,000 CKB in transfer transaction we just made. So this is what we have for the initial version of CKB Studio web version. We are still working on this project and adding more features. And this project, including the desktop and the web version of CKB Studio, is open source on GitHub. You are welcome to check out our GitHub repo, and if you find any bug or want to request new features, please use the issues. And if you like our project, a star would be really appreciated. Thank you very much.
Thanks, Phil. That was great. So the next project up, we have Mike from Obsidian Systems, and he's going to be talking about the Ledger hardware wallet grant.
Hi, everyone. My name is Mike Reinhardt. I'm from Obsidian Systems. And today I'm going to give you a run through of how to use the Nervos Ledger application with Neuron. So you should see I have Neuron open right now, and I also have the Ledger app open on the second screen. And we're going to get started by first connecting the Ledger app with Neuron. And then from there, we're going to do a few examples of different things you can do, such as the full life cycle of the Nervos DAO. We're going to sign a transaction or two, and we'll also sign a message. Now I'm doing this all over a DevNet today that I'm running locally so that I can make things move a little bit faster, and especially things like the DAO. So to get started, I'm going to click down in the bottom left here to open up the preferences for Neuron. And in here, we can go into wallets. And so under wallets, I have just the first wallet that it starts with by default. But then under import a wallet, I can go down and I can select hardware wallet. And that's what we'll do today. So I'll select that, select the Nano S as the model that I'm connecting, and hit next. Neuron is then looking for the application, and indeed it finds CKB app version 0.5.1 running, and that is the latest version as of today. So we'll hit next, and now we have this opportunity to provide public key. It'll list the derivation path, and it will show our address. And in my case, my address ends in 8E5L. Yours, of course, will be different, but we'll accept that, and then we can name it, and we'll name it Ledger Nano S. Import successful. Awesome. So in my case, I've actually done a few operations with this account before, and I already have a balance. But if you don't already have funds on your Ledger device, once you do this connection, you can go to receive, and here you can easily copy your Ledger's address. And so here, for mine, it says 8E5L, which was that address that we saw prompted on my device before. Awesome. So your Ledger app and Neuron are now connected. So next, let's do a deposit in the Nervos DAO. So just like I would for any other account, I'm going to go select deposit, and let's put 10,000 CKB in. We see the transaction fee down here with it's 4 zeros and then 1228, and we can hit proceed, and then sign to sign with the hardware wallet. So on my screen, you'll see it says now confirm DAO deposit. It says the amount, which is 10,000. And then it has the fee, which is 4 zeros followed by 1228. The cell owner, and that should be myself, which ends in 8E5L. Excellent. And this deposit is now set. So if we go back into Neuron, we'll see this transaction completing. Success. Excellent. So for the sake of time, let's go ahead and just start this withdrawal right away. So we'll hit withdraw. We'll see my original deposit amount and the compensation I've received. Proceed. And this prompt is very similar to the last one we saw, except it just says confirm DAO prepare. So we'll confirm the amount, the fee. I am the cell owner, 8E5L. Excellent. We'll accept this. Great. So next, I'd like to show you a sample transaction. So if we go to send, we can put together a transaction. And I'm going to start by just sending 500 CKB to this address. It says my transaction fee is 5 zeros followed by 464. This all looks great. I'll hit send, and then I'll hit sign to send this to the ledger. So on the device itself, we see confirm transaction. We see our amount of 500 CKB, and then we see our fee of 5 zeros followed by 464, and then the destination, which ends in SHNA. Excellent. And you see that this says contract not present. I'll get into that in just a second here. Let's go ahead and accept this, and we've just signed that transaction on the device. Now, while we're looking at the app here, there's a couple things I want to call out. First, my device just has this little square in the bottom because I'm using debug firmware. Don't expect to see that on your own device. Next, I want to cover some of the configurations that we have. So if we go into configuration, we'll see 3 different settings. The first says addresses for, and it says testnet. So Nervos uses a different formatted address for mainnet and testnet. On mainnet, it's going to be CKB at the beginning of your address. And on testnets, the addresses will begin with CKT. And so because I'm doing this demonstration on a DevNet, I've selected addresses for testnet, and that's what will show up on the device. Second is allow sign hash. So there's 3 different types of messages you can sign in Nervos, and all of 3 of them are supported with the Ledger app. You can sign the raw string, so you could actually see the message, the text that you want to sign on the device. We'll go over that in just a moment. You can sign binary hex, and you can sign a hashed message. So if we're just signing hash data, the device can't verify any of that. And so we need to relax the security model a bit by just saying, hey, okay, we're going to turn on allowing the signing of a hash. But you have to have this setting turned on to sign hash data. Finally, we see allow contract data, and this is turned on. Now what this does is it allows you to sign any cells that have custom contract data on them. So if you want to sign an SUDT or an ACP, anyone can pay, you should turn on this setting in the app. And this version will allow you to sign all those different types of SUDTs, and you can do so with Neuron. So I'm going to turn this off. Now, when we signed our last transaction, you saw the last field said contract data was absent. If you have this setting turned on and you're signing an SUDT, it'll tell you instead that contract data is present. Okay? Let's turn that back off and go back to our main menu. So we're going to put together another transaction now, but this time I want to show you sending to multiple destinations. So we're going to send that same address from before at 500 CKB, but now let's get another address, and I'm going to hit the plus sign here to add another destination. And let's send 2000 CKB to this second address. So I have two outputs, and here's the aggregate, right? We're sending a total of 2,500, and our fee is 50625. So let's send this, found the ledger, ready to sign. Let's take a look. Again, it starts with confirm transaction, and then it's going to show us the total amount of this transfer. So the total amount we're transferring is 2,500. The fee for this operation, 50625. Then we're going to get to confirm each output individually on the Ledger app. So our first output, number 1 of 2, is for 500 CKB, and that's going to the address that ends in SHNA, and that's what we see here. Output 2 of 2 is for 2000 CKB, and that one's going to go to the address that ends in XNQE, and that is right. So we've now verified both of our outputs individually, plus the aggregate information on this full transaction, and we were able to sign that with our ledger. So you can sign up to 5 different outputs in the same transaction. If you want to do more than that, I recommend you just break it up into multiple transactions. All right, let's go back and check on our DAO deposit. We did the prepare on this already, so now it's ready to be withdrawn. So let's withdraw from the Nervos DAO, and what we'll see here, we'll hit sign. Let's take a close up. We see confirmed DAO withdrawal, the deposited amount that we put in the first place, 10,000, and then we see the compensation. So this is the amount that you've earned from the funds that you've had deposited in the Nervos DAO. We get to confirm that you are the cell owner, 8E5L, that is my address. Excellent. Let's accept that. And now we've done the full cycle of depositing in the Nervos DAO. We've then prepared it for withdrawal and then withdrawn that. There's one more feature that I'd like to show you. And if we go into tools, you'll see the option to sign and verify a message. This is a really great feature if for whatever reason you need to prove that you own a specific address. So you don't want to sign a transaction or something like that to prove that you own an address because that's just an attack vector that you don't want to leave open. Instead, it's really great to just sign a message instead. Now, what's really cool about this is we can actually verify the exact message on the Ledger device. So here, let's just create, we'll say Nervos Townhall as the message. We're going to sign that with the address we've been using. And now let's hit sign. It's connected, ready for signing. Excellent. And then on the device, we see sign message. And then there's the exact string that we wanted to confirm. Nervos Townhall. Excellent. Let's accept that. Now, also with Neuron, we can verify that the signature we just produced is for a given message and address. So we made this signature when we just signed. Now, using this verify button, we can verify the signature is for this message and this address. Now, if I were to change the message and try and do this verification, that's going to fail because that signature is for a different message, right? But if we restore the original message and then we try and verify that this signature was made by this address with this message, we'll see that verification succeeds. So this should be a really good introduction for using the Ledger app with Neuron. If you have any questions, we'd be more than happy to answer them. And if you want to check out the Ledger repo itself, it's github.com/Obsidian Systems/Ledger@Nervos. Thanks again, everyone.
Thanks, Mike. So last but not least, introducing Mwaa from Leap Dao, and he's going to be talking about the CKB sidechain framework grant.
My name is Mwaa Joseph, and I'm here to talk about the grant that we received. So the grant was to build a sidechain framework that will allow anyone to easily launch a layer 2 network on top of Nervos. So this grant was awarded to Leap Dao, which is a decentralized community of developers who specialize in building of layer 2 solutions. So the first phase was to build a trusted bridge, whereby the trust will come from an audit safety margin, where a trustee could hold the bridge transactions if they deemed any of the transactions to be invalid. The trustee can be anyone, either Leap Dao or a trusted third party during the deployment of the bridge. So the child chain is EVM based, and currently we are using the project Ethermint, which is a Cosmos module. So some of the core features that we were able to implement are the bridge state transition and a validator coordination server. The bridge state transition are actually the bridge scripts on Nervos chain that can exist in 3 states: the bridge deployment, user deposit collection, and user payouts. So during bridge deployment, we collect the validators' addresses, and we will support staking in milestone 2. So these states allows us to ensure that transactions that are carried out have one output that will modify the state. So this restricts to a single payout or single deposit that will change the bridge capacity. The validator coordination server is based off Docker containers, which contain everything that is needed to start a validator node. So the first validator starts the node, and this triggers a Genesis process that provides a config file that the second and subsequent validators are able to request. So once the second validator requests a config file, they are able to also generate their own transaction, and once they generate this, they send it to the first coordinator, and the first coordinator compiles this and records them as a peer. Once enough peers needed to start the chain are online, which is 2 out of 3, the sidechain will start block generation, and thereafter any validator who joins just simply asks for the config file, and they send their node details and are recorded as peers. So the challenges we've experienced so far are the reliance on an external maintainer for the EVM chain. You find that issues and bugs that we report are subjected to the maintainer's capacity to resolve them. We also experience the challenges of several iterations of the architectural design to ensure that we meet and fit the CKB model designs. So what are next steps? Our next steps are to ensure we support more EVM projects such as Polyjuice and actively support maintaining of such projects. This will ensure that moving forward, the sidechain framework will have stability in the dependent EVM chain used. Secondly, we'll also be looking to launch a test network on Nervos testnet and have public participation in this to ensure that we can easily have a readily available layer 2 network. Secondly, moving on to milestone 2, we'll be adding validator staking on the child chain and also evaluating the token economics of a single use token for all layer 2 networks that will be deploying on Nervos network. Thank you for listening.